Hi there, in this video we are going to look at point-slope form, which is a form of linear equations. Similar to y equals mx plus b, which is slope-intercept form, point-slope form can be used to graph lines as well. So point-slope form is this right here, y minus y1 equals m times x minus x1. Notice we have an m just like in slope-intercept form, which still represents the slope of the line, which is the rise over the run. X1, Y1 together form an ordered pair that is just a random point on the line. So with slope-intercept form, we used M and B represented that y-intercept. But with point-slope form, we just have a random point on the line represented by x1, y1 written together as an ordered pair. So x1 and y1 together represent a point on the line. So to graph in point-slope form, we are going to follow these three steps. We will start by plotting the point x1, y1. So the x1 and the y1 come together to be one ordered pair that will be a point on the line. From that point, you will use the slope, the rise over the run, and we will plot at least one other point on the line, but you can plot all other points within that range or as many as you can using the slope. But really, you only need at least one other point to create that line. So let's take a look at this first example. Y minus 3 equals 2 times x minus 1. So let's start with our x1, our y1, and our m. Let's write those out. So x1, I'm going to write the formula underneath it. So our 3 is representing our y1. And then our 2 is representing our m. And our 1 right here is representing our x1. So we can see the numbers in those x1, y1, and m places. So x1 is the number 1. Notice it is not -1. The minus sign is part of the general formula. So then we just use the 1 as the x1. Same concept with the y1. y1 is 3, and m equals 2. So we know that the slope is 2, which can be written as well as 2 over 1. That's our rise over our run. Our x1 and our y1 go together to be an ordered pair, 1, 3. So what we are going to do is we are going to start by plotting the point 1, 3, and then we'll use the slope to find at least one other point. So we go from the origin, right 1, up 1, 2, 3, put a point. That is your x1, y1, your random point on that line. And then we're going to use our slope of 2 over 1. So our rise is 2, so we go up 2 over 1. And you can plot a point there and call that your line. You can connect those points, and you can extend it in both directions, put your arrows on the end, and that can be your line. So that can be where you stop. If you wanted to continue, you can continue to see additional points as well. Really, it just depends what the question is asking, and if you don't need to, then don't spend the time doing the extra points. But if they are asking, for example, where it might cross the y-axis and you choose to go by graphing, then you might consider going and plotting the other points this way. Down 2, left 1, put a point. Down 2, left 1, put a point. So again, it really just depends where you are looking on the graph or where you need to look on the graph. And then you would just, again, connect those points with a line and put arrows on the end of the line to indicate that it does go on forever. So again, you may not need to graph the entire line on the test depending on what the question is actually asking. So let's take a look at number 2. Y plus 2 equals -1/3 times x minus 1. So again, I'm going to write that equation, y minus y1 equals m times x minus x1 underneath. And let's go ahead and write out our x1, y1, and our m. So our x1 is going to be 1. Our m is going to be negative 1/3. And our y1 is going to be a little bit different. So our y1, notice that this is y minus y1. However, in the equation that we are given, it turns into a plus. So we have to think about what did we plug into this spot right here to make this turn into y plus 2. And if you think about it, to turn it into a plus, we would have had to put a negative number in this spot, in the y1 spot. So if I had written y minus negative 2, minus negative 2 is what becomes plus 2. So negative 2 is what goes in for y1 to turn it into this plus 2. It's essentially like the opposite of what it appears in terms of signs. So we see plus 2, that really means we put a negative 2 in that y1 spot. And then here, it looks like a negative 1, but we really just put a positive 1 in there because it already had a negative sign there. So our x1 is a positive 1. And then m is just whatever it is, negative 1/3 in this case. So our ordered pair comes from these two numbers. So 1 comma negative 2 is our ordered pair. So from the origin, we go right 1 down 2, put a point, and that is the start of our line, or 1 point on our line. And then we go ahead and use negative 1/3. So this is our rise of negative 1 and our run of 3. So we're going to go down 1 because it's negative 1, and then run 3, which means positive 3 is to the right. So 1, 2, 3, put a point. Again, that's technically all you need. If you want to, you can continue going down 1, right 3, put a point. Or you could go from the other direction, up 1, left 3, put a point. Up 1, left 3, put a point. And we can continue that way instead. It's really just, again, what the question is asking or what you actually need for the graph. So that is graphing in point slope form. So in summary, we talked about point slope form, which, remember, point slope form is y minus y1 equals m times x minus x1. And our x1 and our y1 come together to create an ordered pair. And that ordered pair, x1 comma y1, is a random point on that line. And then remember that m is our slope. All right, and graphing in point slope form, you're always going to start at this ordered pair, this x1, y1, and then once you have started wherever that is, you're going to use your slope to work your way up and over or down and over, whichever direction, depending on the sign of the slope. And we are going to continue to put at least one other point, and then you can connect those points to create that line. But if you want to, again, depending on what the question is asking, you can continue with that slope along the line in either direction.